Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on factorization. So this is actually the opposite of expansion. We looked at expansion in a previous video. So we have something like 2 outside of x plus 5. We can use the distributive law to expand it. We just go 2 times x and then 2 times 5. So I went this way. I started off with a bracket, ended up with no brackets. That's called expanding. But now what I'm going to do is look at going the other way. So if I start with something that looks like this and end up with this going this way, that's called factorizing. So we call it factorizing because what we're doing, we're starting off with two terms here, 2x and 10, and we're writing an equivalent expression that is something times something. We're writing this as two things multiplied together. 2 is one of those things, x plus 5 is the other thing. That's what factorizing means. Like you can factorize 36 by writing it as 9 times 4. We're starting off with an expression and writing it as something times something. So how do I actually do that? Well, let's say I start off with something like 4x plus 20. I want to write that as something times something. So when we're factorizing, we're going to end up with brackets. So we're going to have some brackets here. So what goes out the front of the brackets is the highest common factor of the term. So here 4x is one term, positive 20 is another term. So the highest common factor of these two terms will go out the front. And then inside, what you do is divide each term by the highest common factor. So what is the highest common factor of 4x and 20? So we need the highest number that goes into 4 that also goes into 20. Well, that's just 4. So what we're going to do is write 4 out the front and set up our brackets. So in the brackets, we go 4x divided by 4. Another way of thinking this, what do I times by 4 to get 4x? So of course you need to times by x. What do I times by 4 to get positive 20? Well, that's positive 5. Okay, and then we're done. So this is the final answer. This is factorized as it's something times something. This is an expanded form because there are no brackets. It's not something times something, it's something plus something. So if I were to expand this using the distributive law, I would get this as my answer. So that's how I can check. All right, let's look at another example. So 12y minus 28, I want to factorize it. So I'm going to first find the highest common factor. So the highest number that goes into 12 that also goes into 28 is again 4. So I say, what do I times by 4, the highest common factor, to get 12y? Well, I need to times 4 by 3 to get 12, and then I need to have a y there as well. What do I times by 4 to get not 28, but negative 28? Well, I need to times by negative 7. So once again, if I expand this using the distributive law, I get this. What is left in the bracket should have no common factors, and 3 and 7 do not. Let's look at another example. So once again, we have something, an expression in expanded form, and we're going to factorize it, write it as something times something. So we need to first find the highest common factor of 15ab and 35a. So the highest number that goes into 15, but also goes into 35, is 5. But note, both terms have an a. That's also a common factor, so I also need to write the a out the front. This time I've written the a because it's in both terms. I didn't write the y out the front in this example because there wasn't a y in both terms, but here there's an a in both terms. So same process as before. What do I times by 5a to get 15ab? Well, I need to times by 3 to get 15 and the b, so it's an ab. What do I times by 5a to get negative 35a? Well, that's just negative 7. Now, what about if I had something like this? Well, this is a little complicated. I still kind of have, if you like, one term, two terms, and I can factorize this further. It just looks weird because I've already got some brackets. So how would I factorize this? Well, I'm going to use the same principles I've been using in all the other examples. So I'm going to write the common factor. I'm going to write what's common out the front. So the thing that's common to this and this is what's in the brackets x plus 1. So I'm just going to write x plus 1 out the front. So then, no different to how I've done in the previous examples, what do I need to times by x plus 1 to get this? Well, x plus 1 has been times by 4 here, so I write a 4. What do I times by x plus 1 to get this? Well, here, x plus 1 has been times by negative y, so I'm going to put a minus y there, and then I'm done. So it turns out, if you were to expand this, you would get this. They're actually equivalent expressions. Of course, to expand this, you need to use FOIL that we learned in previous lesson. Okay, so we're going to, in subsequent lessons, apply this factorization idea to quadratics. But for now, that's all there is. Thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.